In this video, we're going to solve inequalities, specifically 1- and 2-step inequalities. If you already know how to solve 1- and 2-step equations, then solving inequalities is going to be very easy. There's only one thing you need to keep in mind when you are working with inequalities. Some things to keep in mind as we work with inequalities are that the goal is to isolate the variable, just like with equations. We're going to use inverse operations, just like we did with equations. And the inverse operations are addition and subtraction, and multiplication and division. And finally, we're going to balance the inequalities for each step, which is the same thing we did when we solved equations. The first thing we're going to look at is solving inequalities using addition and subtraction. Looking at my first example, I have x plus 5 is greater than negative 7. I need to isolate my variable x, and I look at the operation that's going on the side of the equation with the variable, which is addition. We undo addition with subtraction, so I'm going to subtract 5 from both sides of the inequality. And I'm going to clean up my equation now. I bring down the x plus a 5 plus a negative 5, or 5 minus 5 is 0. I bring down my greater than symbol, and negative 7 plus negative 5 is negative 12. And now I'm going to drop the 0, so all I have left is my solution to my inequality, which is x is greater than negative 12. Now, one extra thing we have to do when we solve inequalities is graph the solution set. So I'm going to make what I call a cheesy graph, where I just put 0 and the solution number on the graph. And because it is a greater than symbol, that means at negative 12 I'm going to have an open circle. And as I look at my solution set, it says x, which is all of my solutions, are greater than negative 12. Well, for my solutions to be greater than negative 12, they need to go to the right. In our second example, we have x minus 6 is less than or equal to 1. I'm going to isolate my variable x, and I look at the operation that's going on the side of the equation with the variable, which is subtraction. We undo subtraction with addition, so I'm going to add a positive 6 to both sides of the inequality so that my inequality is balanced. I rewrite my inequality as x plus 0 because negative 6 plus a positive 6 is 0. I bring down my inequality symbol, and 1 plus 6 is 7. I'm going to drop that 0, so I end up with my solution as x is less than or equal to 7. So again, I'm going to graph that solution set on a cheesy graph, and I'm going to put 0 and 7 on my graph. This is a closed circle because that is a less than or equal to symbol. And as I read it, it says my solutions are less than or equal to 7. So for my solutions to be less than 7, my solutions need to lie to the left of 7. Now we're going to look at solving inequalities using multiplication and division. In my first example, I have x divided by 2 is greater than 11. The operation going on the side of the inequality with the variable is division, and we undo division with multiplication. So I'm going to multiply both sides of my inequality by 2 so that I'm balanced. My 2's on the side of the inequality with the variable cancel out and leave me with x. My greater than symbol comes down, and 11 times 2 is 22. So my solution is x is greater than 22. And if I graph that, I have 0 and 22. I will have an open circle at 22 because it's a greater than symbol. And my solutions are greater than 22, which means they lie to the right. Now we're going to look at our second example, and it is negative 8 times x is less than or equal to 56. In this example, I have a negative coefficient, and this is one of the few problems that we need to do something different when we're solving inequalities. And whenever we multiply or divide an inequality by a negative number, we need to change the symbol from what it is to its opposite. So when we solve this problem, and I divide by negative 8, I'm going to have to change this less than or equal to symbol to a greater than or equal to symbol. So the first thing I'm going to do is divide both sides of my inequality by negative 8. My negative 8's will cancel out and leave me with x, and 56 divided by negative 8 will be negative 7. And now because I divided by that negative 8, my new inequality symbol is a greater than or equal to symbol. So my solution is x is greater than or equal to negative 7. And if I graph that, I have 0 and negative 7. I have a closed circle at negative 7. And my solutions are greater than or equal to that negative 7. So my solutions would lie to the right. All right, let's try solving some two-step inequalities. In my first example, I have 5x minus 4 is less than or equal to 11. I'm not going to have to worry about changing my symbol for this inequality because the coefficient for this problem is a positive. We only need to change the symbol to its opposite when we have a negative coefficient, and we're not going to have to worry for this problem. So I'm going to proceed as normal. I'm going to look at my constant, which is a 4, and the operation on the side of the inequality with the variable is a subtraction, and we undo subtraction with addition. So I'm going to add 4 to both sides of my inequality. I'm now going to clean it up and bring down my 5x. A negative 4 plus a positive 4 is 0. I bring down my less than or equal to symbol, and 11 plus 4 is 15. I'm now going to drop that 0 because it's not necessary, and I have 5x is less than or equal to 15. The operation going on the side of the inequality with the variable is multiplication, and we undo multiplication with division. So I'm going to divide both sides of my inequality by 5. My 5's are going to cancel out and leave me with an x. I bring down my less than or equal to symbol, and 15 divided by 5 is 3. So my solution is x is less than or equal to 3. All right, let's look at our next example, which is x divided by negative 4 minus 10 is less than or equal to 2. Looking at this negative 4, I know that at some point in my solution of this inequality, I'm going to have to multiply both sides by a negative 4. Because I'm going to have to multiply by the negative 4, I know that I'm going to have to change that symbol to its opposite, and it's going to become a greater than or equal to symbol. So I'm just going to write myself a little reminder down the bottom that when I finish this problem, I should have a greater than or equal to symbol when I look at my solution. So now I'm going to proceed as normal. On the side of the inequality with my variable, I have subtraction. I undo subtraction with addition. So I'm going to add 10 to both sides of my inequality. My x over negative 4 comes down. Negative 10 plus positive 10 is 0. I bring down my less than or equal to symbol, and 2 plus 10 is 12. I'm going to clean up my problem, so I have x over negative 4 is less than or equal to 12. Now I have division going on the side of the inequality with the variable. I undo division with multiplication, and I'm going to multiply both of my sides by a negative 4. My negative 4's are going to cancel out and leave me with an x, and 12 times negative 4 is going to be negative 48. Now I'm looking at this symbol that I drew, and it's telling me, remember, you multiplied by a negative, so you need to change that symbol to its opposite. So I'm going to change it from a less than or equal to a greater than or equal to symbol. So my solution is x is greater than or equal to negative 48. This is the end of the video on solving 1 and 2 step inequalities.